So today, good afternoon, I'll be discussing to you chapter 6, which is case-based reasoning. Let's begin with. So I'll give you a scenario here before I start discussing to you the topic. Let's say, for example, there is a manager here and he wants to shortlist an applicant, he wants to shortlist applicants for the MIS manager position in the company. So this guy has 3 applicants and he wants you to help him to select which of the 3 applicants should be hired. So look at this now. So the first applicant is a PhD holder. He has 3 years experience and he is 35 years old. So he is expecting a salary of 2,000 Omani Riyal. And then here comes the second applicant. He has BSc in IT and then he has 15 years experience and he's 30 years old. So he's expecting 3,000 Omani Riyal salary. And lastly, we have the third applicant. He has MSc in IT and he has 7 years experience and he is 28 years old. So he's expecting to be paid with a salary of 2,500 Omani Riyal. Now, if I'm going to ask you to select which among these 3 you should select and hire in the company, who do you think is the best candidate? Anybody from the group? Anybody can tell me? Based on this, which you will hire, and tell me why. Anybody?
Doctor, second one.
The second one.
Yes.
Another one? Thank you, Ibrahim, for the answer. How about the other students, which you will select? Tariq, Khalid, who you will select based on the 3?
First one.
The first one. How about Khalid? Khalid is here. Who you will select, Khalid? If you will be the manager and you will be choosing among the 3 people, who you will select? How about Riham? Riham, if you will be the manager, who you will select?
The last one.
The last one? Could you please, the 3 of you, Ibrahim, Tariq, and Riham, could you please tell me your reasons why you chose the persons you have chosen earlier? What are the reasons?
Hi, Doctor.
Yes. Why did you choose the person? For what reason?
Doctor, I'm change. I'm lose second one.
Yeah, why? Why?
Because have
Doctor,
more experience.
Okay, so you base your answer on the experience. Okay, so
Yes.
based on Tariq, he will be choosing the second one based on the experience. How about Ibrahim? Why did
yes, Doctor, because he has 15 years experience.
Okay, you choose a 15 years experience.
And salary, not more, not much.
Not much. Actually, he has the highest. 3,000 he's asking. The first one is
Yeah, but 15
2,000
years he work already.
in the experience, huh?
Yes,
Also,
because
he
the
is a
first
young,
one,
Mm-hmm.
30 years.
But look at the age. Do you believe that he has this experience, 15 years? He's only 30, according to his years, right?
yes,
Do you believe that he has this experience already within the 30 years old?
maybe he work young. He start to work.
At 15
Maybe
years.
he live another country, not an Oman.
Maybe his father shop he work.
In the shop of the father. Okay, very good. I'll give you another situation. Now, this guy, the manager, is shortlisting applicants for the MIS manager, same position. But this time, he's looking for this MSc in big data, at least 5 years experience, and salary expectation is 1,800 OMR. So this time, there are criteria for the selection. Okay, remember the selection criteria: MSc in big data, at least 5 years experience, and salary expectation is 1,800 OMR. Now, these are the applicants. I am a PhD holder. I have 3 years experience and I'm 30 years old. I expect OMR 2,000 salary. The second one, I have a BSc in IT and I have 15 years experience and I'm 30 years old. I expect OMR 3,000 salary. Then the third one, I have an MSc in IT. I have 10 years experience and I'm 30 years old. I expect a salary of 2,500. So based on this criteria, okay, who will you select from the three? Question, is the selection now easy or it became more difficult?
Actually, it's more difficult.
Yeah, right? It became more difficult because we now included criteria, right? So when we included the criteria, selection became more and more difficult. So the problem now is we don't know which one to select, right? So
Right.
this is our problem because we involve the criteria. Let me just close this for a while. Now, let me tell you, actually we have 1,000 applicants. So how we will select then? Look at the situation, right? When we have the first example, we did not set any criteria. So selection is quite easier as long as you know the parameters, right? The qualifications of each applicant. In the second scenario, what we have noticed is that we have the criteria and selection became more difficult as we involve the criteria. But what made our process more challenging is we have 1,000 applicants. It's not only 3. So how will perform selection in that case if we have 1,000 applicants? So in this case, manual selection and manual placement will be challenging for you. So in this case, we have to go with the next artificial intelligence technique, which is case-based reasoning. So from the word itself, it says case. We're going to make reasoning based on existing cases. Meaning, from our past experience, we're going to do reasoning. We're going to make reasoning based on our past experience. So in this lesson, you're going to learn what is CBR, how does CBR works, and what are the cycle on the CBR system. And you're going to learn the similarity in CBR. And then we will compare case-based versus rule-based expert system. Then how do we represent knowledge in both case-based and rule-based. And then we will go with the type of applications that case-based reasoning is being applied for. Let's begin with the definition of CBR. So look at this one. Case-based reasoning is an act. Okay? It's an act of what? It's an act of developing solutions. Okay? So we have a problem to solve. We call this the new problem. Okay? This new problem, we want to find a solution. Okay? We want to find a solution to the new problem. So what we will do is, using CBR or case-based reasoning, we're going to solve this new problem using the pre-existing solutions. Meaning, we're going to compare the old problem with the new one. Okay? The new problem. Okay? So we have a new problem and we have an old problem. So what we will do is, the solution we use for this old problem, we're going to apply it with the new problem. So this is how we use the case-based reasoning. That is why they call CBR as expert system, or they call it the knowledge-based systems. It means that our CBR system is providing solution to the new problems based on the previous existing solutions we stored on the knowledge base. So meaning, all the existing solutions are stored on a database, and we call that database our knowledge base. Okay? So this knowledge base contains all the solution from past problems, and we try to compare new problem with the old problem. So what do we do is, if the old problem is somewhat similar to the new problem, and then we apply the solution to the new problem. It's like you are learning from your experience. So CBR is actually learning from experience. So you have to remember that. Learning from experience. So you apply the solution for the new problem from your old experience. So meaning, the more experience our CBR system, the more expert it will become. So you have to remember that. So the more experiences or the more cases is stored in the database, the more expert the system would be. It's like on the first example, right? So Ibrahim and Tariq said, I'll be choosing the second applicant because the second applicant has more experience. And we know for a fact that the person that has more experience is more expert, right? So same thing in the CBR system. If our system has too many cases solved in the past, and then our system will be more intelligent. So the more experience it has, the more it becomes intelligent. So, in the CBR system, we have this cycle. Okay, so we have this cycle in the CBR. So basically, we have the problem, we call it new case. This problem, we call it new case. So when you hear the word problem, it's also same as case, okay? Don't forget it. The word problem is also the same as the word case. So if you have a new problem, and then you have a new case. So what we will do is that we're going to retrieve, okay? We're going to retrieve from our knowledge base, okay? So these are the list of previous cases. So meaning we have previous cases or problems that we solved in the past, and they are stored in our database. So what are stored in this database are actually list of problems and their solutions. Okay? So inside this would be problems and solutions. So what are we going to do now is we're going to retrieve. We will retrieve all the problems from our database that has similarity with the new problem. Okay? So what we will do after retrieving the case, we are going to reuse. Reuse means the solutions that we have from the old problem, we're going to apply it with the new problem. As I've told you earlier, if the old problem is quite similar to the new problem, and then we're going to reuse. What are we going to reuse here? The solution. Okay? So this reuse phase or this reuse cycle now will suggest us a solution. Okay? From the solved cases, meaning from the solved cases here, we're going to suggest a solution. Okay? Now, if the solution to the problem is found based on the existing old solutions, and then we just simply reuse it. If not, we're going to revise it. Revise it means we're going to create our own solution to the new problem, or we just revise, meaning we just have to revise the old solution and modify it or change it. And then after this, we put it in our database. We retain it. Retain means keep. We are going to keep it. So what happens now? Your new problem becomes part of the knowledge base. Okay? It becomes part of the knowledge base. That's why I told you our system becomes more intelligent as time passes by. For the reason, as we encounter a new problem, we find a solution. After we find a solution, we retain it in our database. So in that way, new problems, new solution, new problem, new solutions, we collect and collect and collect and collect. So next time now, what happens is, if a problem is encountered, we just have to retrieve it and check if it's the same. If there is a solution, what we do is, if there's a solution, we reuse it. If there's no solution, we have to revise it. So these are the cycles on the CBR. Any question here? Any question?
Doctor, I have a question.
Yes, ask me please.
Let's retrieve the old problem. You understand my?
I don't get it. It's because a child is talking at your back.
Yes.
Could you please repeat your question?
Can you back the drawing, please?
Okay.
After new case.
After?
It's a new case.
After which
Some
one?
new case.
New case. New case. You mean new case? Okay, tell me.
Some retrieve.
Retrieve, yes.
My question about retrieve.
Yes, tell me.
That mean it retrieves the old problem?
Yes, similar to our new problem.
Okay.
We're going to solve it. So there will be, on the next slide, you will see it in here. Okay, this is what it says, the summary of what I am discussing earlier. So we have retrieve. We're going to find similar problems. So Khalid is correct. We're going to look for old problems that we have in our database here. And then we're going to reuse. If the old problem is same with the new, we're going to reuse it. Okay? So it's like this. Let me just draw it. If new is similar, this symbolic means similar, okay? If new is similar with the old, then we're going to reuse only, okay? If the new problem is not similar or not near to the old problem, okay, let me just emphasize it here. It's not the same as the old. We're going to revise it. Okay? I'm going to revise it. Clear? So either reuse or revise, we have to go with retain. Both of them. Okay? You have to retain the new problem. Is it clear, Khalid?
Yes, doctor, it's clear.
Okay, thank you so much. So it becomes a cycle, okay? It becomes a cycle. It repeats again and again and again. So let's go with the first cycle and let me discuss it to you in detail, the first cycle. So the first cycle, we call it the case retrieval. This is very important, okay, in the CVR cycle. So we have to design a very good algorithm that is capable on retrieving, if not the same problem, at least similar problem, okay? Normally our target, as much as we can, is to look for 100% similarity, okay? Because in CBR, we have an assumption. We have an assumption actually, okay? We assume that same problem have the same solution. This is our basic assumption in CVR. You have to remember this. Similar problems have similar solution. That is why, as I've told you earlier, our target is, if not 100%, problem 1, okay, is equal to problem 2. 100%. This is new, this is old. If not 100% similar, at least there is this similarity among the two. Because you have to remember, if the reasoning is very poor, and then you will have a very poor solution to the problem, right? So meaning, reasoning comes from a very effective similarity measure. So if the similarity measure is not correct, it's not effective, and then we go with poor reasoning, So if we have poor reasoning, then we have poor solution. So we have to look at that. So we have to design a similarity measure that could lead to a very good reasoning, or else we won't be able to arrive to the right solution to the problem. Actually, we have plenty of approaches. We have many approaches when it comes to the measurement of similarity in CBR. We have plenty. You don't have to worry about it. All you have to do is to choose. And in this presentation, I'll be presenting to you a technique on how we solve or how we calculate the similarity for the CBR. Okay? So, similarity measure, the one I'm discussing earlier, our goal here is to arrive at least 100% equal, at least equal or similar to 100%, and we want to match our previous experience or case with the new problem. Okay, you have to remember we are focusing on the new problem, and you want to provide solution based on the old problems we encountered in the past. So similarity measure is the heart of CBR, meaning if we fail on the similarity measure, and then CBR also fails. So you have to remember, if this one fails, CBR also fails. That's why we have to focus and we have to calculate properly the similarity measure here, because if we will commit mistakes on the similarity measure, and then CBR won't give us a better solution. So what is the purpose of similarity? Similarity means looking for the same problem and we adopt the same solution. So we just simply do either adopt or revise the solution, right? So similarity may lead us to two results: either to adopt the solution, use it right away, or you can modify it. So this will be the end effect of the similarity, either to adopt or simply copy or modify the existing solution. So this is very important. So the basic assumption is that if the old problem is equal with the same problem, and then we just simply use the solution. We just copy the same solution. So our goal is to model a good approximation of the similarity. So the key concept here is, if the similarity measure is correct, reasoning is correct, and then solution is correct. So we have an example here. Okay, let me just open it. We have an example here, and I'll just discuss it to you later. Can you see my screen?
Yes.
Good, thanks God. Let me just look for the case-based reasoning here. Okay. So this is our problem here. Let me just make it big for you to read. Okay, so we have table 1, and we're going to make a case base for the spillway gate decision for Kwantan Dam. You know a dam, right? You know a dam, right? So dam is a structure that controls the flow of water. Okay, normally this is used to irrigate farms, and normally the water coming from dams are from floods and from rains. So we have 4 dams here. We have Pahang, we have Soy, we have Pekan, we have Gambang, and then we have a gate here. Okay, so by the way, we have to decide properly whether to open a gate or not for the spillway. So there is a gate, okay? So meaning, let me just draw it in the whiteboard so that you will see what I mean. Draw it so that you will see it. Normally a dam is like this. For those who don't have an idea what's a dam all about. So a dam is actually like this, okay? So there's a gate in the dam, and then water flows on the dam, okay? So this is a dam. So normally a dam is connected to many rivers, wadi, okay? We have wadi connected to the dam, okay? So in this example that we have 1, 2, 3, 4 rivers. So we have Wadi 1, we have Wadi 2, we have Wadi 3, and we have Wadi 4. So there are 4 rivers where water is flowing to our dam. So this dam is used to control the flow of water before it goes to somewhere else. And normally some countries in the world, they use dams to generate electricity. Okay? They use this to provide electricity. They connect, there is this turbine in the dam, and they use it to generate electricity. That's why they control the flow of water. And the flow of water here controls this turbine. We call it turbine or turbine in English. And this turbine, when it rotates, it produces electricity. That's why they control the flow of water here. Okay? But sometimes during rainy season, too much rain coming, especially in Malaysia. This example is from Malaysia, okay? Sometimes too much rain is coming, and these rivers, they have plenty of water, and too much water is being supplied on the dam. So the water level on the dam is increasing very high, and if the dam is full of water, there is a danger. Okay, the danger is if the dam will explode, what will happen? If the dam will explode, what will happen? So if the dam will explode, what will happen is the nearby cities or the nearby towns near to the dam will be flooded, will be submerged with too much water, and many people will die. That is why we have a spillway, okay? So the role of the spillway is to control the flow of water in the dam, okay? We design it in such a way that when the dam is full, we have to release water here. We have to open the gate. We have to open the gate and release water from the dam because water from the rivers or from the wadi are increasingly very high. So it's very dangerous that if we keep the door closed here or the spillway closed, the tendency is the dam will get full of water and will break. And when it breaks, it's more disaster to the nearby cities. So our problem here in this example is we have to make a decision system wherein we decide whether to open or close the gate of the dam based on the level of waters on the specific rivers here. Okay? So initially, this is the level of the water from the dam, which is this level of water here in the dam, inside the dam. And then we have the level of waters from the 4 rivers. First river, second river, third river, fourth river. So we have levels of water from this 4 river. Okay? So what we are monitoring is we have to check these 4 rivers and also the level of water here. So based on the past experience, look at this. Based on the past experience, on day 1, when the level of water in the dam is 29.26 meters and the river is 11.6 and the river Soy is 30.40 and then Pecan is 15.99 and Gambang is 23.0, the solution is we have to open it. Okay, we have to open it. And on day 2, when the water level of the dam is 28.99, the river is 13.9, soy is 29.1, pecan is 17.09, gambang is 20.99, the gate is closed. And then on day 3 and day 4, same thing. We have here close, and then we have here open. Okay? So these are the situation, and these are the these are the results. Okay? So it means that if you're going to look at it, this could be your old problem, and this is your solution. This is your old problem, and this is your solution. This is your old problem, and this is your solution. In this example, we only have four experiences or 4 problems in the past, and we have 4 solutions also, either to open or to close. Now, but based on the given here, please look at this one. Can you read it? Can you read it? Can you read?
Yes.
Okay. So from this paragraph, it says, the expert said that Wadi Pahang and Wadi Pekan are the most important attributes. So, and the attributes are twice the value of the other attributes. So based on this example, Pahang and Pekan, they have twice attributes. So let me copy this. Let me put it in my whiteboard. Okay, can you see it, right? In my whiteboard.
Yes.
So this is our given. But based on our situation here, it says that Pahang, River Pahang, and the other one is Pekan. They have value of 2. Okay, 2. Pekan is, so it has 2. In CBR, we call it weights. Okay, we call it weights, meaning some attributes, we call them these attributes, they have weights with them. They have weights. So since Pahang and Pekan are the most important rivers that we declare if you're going to open or close the gate, so we have to give them weights of 2. So this is the given example here. So the problem now is this. On day 5, this is our problem. Our problem now is day 5. Our problem on the day 5 is this. So look at this. On day 5, the dam water level is 29.50, River Pahang is 12, River Soy is 20, Pekan is 22, and Gambang is 20. So the question is, our question now is, what would be our solution? Gate, we don't know. Is it open or close? Okay? Do you get it clearly, the situation here? What do we want to solve?
No.
No? Okay, I will repeat the situation here. Okay, so there is two decisions. There are two decisions here, either to open or close the gate. Okay, so we have two decisions here. So mostly, or we call it actually this. We call this the. Actually, we call it the solution. Okay, this is a solution. Okay, and this are actually our old problems. Old problems. Okay, these are our old problems. Okay, so you have to remember we only have two solutions: open or close the gate. We open the gate based on this situation, okay, or close the gate based on this situation. This is the past record, or this is the past database of the dam, okay, past database of the dam. Okay, so during this time before, if the water level of the dam is like this, or the river level is like this, or like this and like this, for the four rivers, they open the gate. Okay, and for the second day, if the dam level is like this and the river levels are like this, then we have to close it. So if you will see, we have different solution, or we have different decisions based on the attributes, right? So the solutions or the decisions of this, either to open or close the gate, is based here on the attributes, this one. So we call this the attributes. Okay, all of these attributes: the dam level, the river level, the river Pahang, the river Soy, the river Pecan, and the river Gambang. So the decision is either to open or to close the gate based on these rivers. Now, on day 5, Khalid, on day 5, we have this situation. The dam water level is 29.5, Pahang is 12, Soy is 20, Pecan is 22, Gambang is 20. So our question is, what are we going to do with the gate? Are we going to open or are we going to close? Based on these situations we had in the past, with the past experiences, what do you think would be our decision on this new problem here, which is the problem is on day 5. What do you think would be the solution? Are we going to open or are we going to close the dam? Anybody from the group can give me an answer?
I think it's closed.
Closed?
Yes.
Why? Why we're going to close it?
Because the highest level of drum in the day 3.
29.5. And then?
Yes.
But look at this, Khalid. We don't only look on the dam. Not only the dam, we also look for the river Pahang, and also river Soy, and also river Pecan, and also river Gambang. We don't only look on the water level. So on the dam water level, we have 29.5 here, which is day 3, right? Merely looking on the dam water level, we have 29.5, which is day 3. That's why Khalid says we're going to close it.
Yes.
But look at river Pahang. River Pahang is 12. So river Pahang is quite similar here, right? Which is 12.89. How about river Soy? River Soy is 20.99. How about river Pecan? River Pecan is 22. So the problem is we don't have 22 here on river Pecan. So we don't know which one to follow here. And then Gambang, it's 20. So we don't have 20 here, but we have 20.99. So we don't know which one to choose, right? Because we have 4 attributes here. So the attributes here will affect our decision making, either to open or to close the gates. So we're going to calculate this using CBR. So using CBR, we're going to calculate, which I will go later as we go with the discussion. So we're going to calculate it using CBR. Is the case now clear? Everybody from the group? Do you get the case now that we want to solve? Anybody from the group? Anybody from the group, please answer me.
We must to calculate.
Which one to calculate?
CBR.
Is the case clear? Do you know what we want to solve here in this problem?
No, we don't know.
You don't know? You don't know what we want to solve here?
Yes.
Why? Is my discussion not
Doctor,
clear? Yes.
here we want to see if we'll open the gate or close the gates.
Yeah, very good, Ibrahim. Very good. So our problem here is we want to know if you're going to open or to close the gate of the dam, right? Based on the conditions of the dam water level and the 4 rivers here. Very good, Ibrahim. So we want to solve this. We want to know, with these situations here, are we going to open the gate or close? Right? So let's proceed with the presentation here. So when we go with the calculation for the similarity, we have 2. Okay, we have 2 calculations for similarity. We have local and global. Okay, let me just go to the whiteboard here. So we have 2 types of calculation. Okay, so we have 2 types of similarity calculation. Okay, you have to remember that we have 2 types of calculation. So the first one is local similarity. We call it also LS. Remember this. And then the other calculation is, we call it the global similarity. Okay, or we call it GS. So we have 2 similarity measures that we're going to do here. This one and this one. Okay, so in the local similarity, what do we do is we're going to compute the similarity between the attributes or the feature. Attributes and feature are the same. Okay, they mean the same thing, attributes or feature. Okay, so in our example here, the dam water level, we call it attribute 1. Okay, so this is attribute 1. Attribute 1. This one. Okay. The first river is attribute 2. Okay. This is attribute 3. This is attribute 4. and then Control Z, Control V, and this one is attribute 5. Okay, so please make note of that. So in the local similarity, we try to calculate. Okay, we try to calculate. Let's say, for example, for the dam water level, what is the difference between this one and with this and with this and with this and with this? So we call it the local similarity. We're going to calculate the local similarity, or simply the attribute differences. We're going to compare. Okay? So for the case of the river Pahang, we're going to compare 12 here with this, with this, with this, and with this. We're going to compare this. For the river Soy, we're going to compare this to this, to this, to this, and to this. Same with Pecan. We're going to compare 22 with this, with this, with this, and with this. For Gambang, we're going to compare 20 with 23, with 20.99, with 21.9, with 19.22. That is what do we call the local similarity. Okay? In the local similarity, you're going to compare attributes. Okay, so make note of that. How about in the global similarity? In the global similarity, we're going to compare the buildup. Okay, the buildup from the local similarity function. It is the weight sum of the local similarity case or object level. So it means in global similarity, what we are comparing is this one here, okay, this one here, dam level Pahang, Soy, Pecan, Gambang as a whole. How do we compare it with this as a whole? Clear? So I want to compare this as a whole to this as a whole. Did you get it? So how similar this one to this one? That is for the global similarity. Okay? So in the global similarity, we want to compare the buildup. Okay? The buildup of all the attributes. Clear? So this is the global similarity. So this is how do we do the calculation. Any question here? Any question? Before I go with the next part.
No, doctor.
Clear? Okay, good. So let's begin. So this is the global similarity, as I've told you earlier. So this is the global. So how do we compare all of this against the other similarities? Okay, so this is how we compute for the global and the local similarity. So you have to follow formula on that one. So local similarity has two cases, numerical and discrete. Okay, let me just write it in here to summarize it. We have two data, two types of cases. The first one is numerical, or they call it continuous, and the other one is discrete. Okay, so we have two types of cases here for LS. Can you give me an example of numerical values or continuous? Example here. Example of continuous. Tell me.
1.
1, 2, 3. Yeah, of course. But give me example of continuous values.
I don't know what continuous.
Continuous means they are expressed in number. You're correct actually. You said 1. So when you say numerical or continuous, the values are expressed in number. Let's say for example, age, right? Height, what more? Amount, etc. So these are examples of continuous because they are expressed in numbers. How about discrete? What are the examples of discrete values? Gender, right? Under gender you have, let's say, male. Gender you have male or female. What more? Can you please tell me another one? For discrete values, for gender we have male and female. What more?
Wife and husband.
Wife and husband. So you mean civil status, right? Very good. Civil status. Yeah. So you call it married or single, right? So these are examples of the two types of cases. So when you say numerical, all of them are expressed in numbers, okay? So when you say discrete, they are normally expressed in words like male, female, married, single, yes, no, true, false, like this. Okay? So don't be confused with this. Because the two of them have their own respective formula to follow. If you are working with discrete values, the formula is like this. Okay, for discrete. Let me just copy it. Alt tab. Okay, so please remember the formula. This is very important. The formula for discrete, okay? So let me just move it here. For discrete value, the formula is this. This one. This is very simple, right? This is very simple actually. Okay, so the formula is very simple. If A equals to B, it's 1. If A is not equal to B, it's 0. It's very simple. The similarity of A and B is very simple. If A equals to B, it's 1. If not, it's 0. So it's very simple for discrete. For continuous, the formula is different. Let me take it for continuous. Okay, for the continuous, the formula is like this. Let me just copy it so that we will know it later. Okay, so for continuous it's like this. The similarity for the attribute of A to B is equal to 1 minus the absolute value of A minus B over the range. So you will have in here, it says A is the new feature and B is the previous feature, meaning A here represents the attribute of the new, okay, new problem. Okay, and this one here represents the attribute of the old problem. We're going to compare it. So we have the range here. We need the range here, which is the value of the difference between the upper and the lower boundary of the set. So this can be expressed with the equation. This one can be expressed with the equation range equals max minus mean. Okay, it's like this. So this equation for the range. Okay, so let me just put it in here so that we will see here. Range equals max minus mean. So you have to remember this. This is how we calculate the local similarity. Ready? Shall we calculate now before we go with the global later? So this is for the local similarity. Okay, we have two, discrete and continuous. So let me copy the same problem here that we had earlier. Let me just get it. Let me erase the one I put. Okay, tell me. Okay, so let me just copy this. Okay, I'll copy, Control C. No, let's press this and shift this one and control. Only one I can copy. I'll copy this one, Control C, and I'll put it on my whiteboard here. I'll take this again. I'll take this one again. It's the problem for day 5. Control C, and I'll go with here. Okay. Ready? Ready? Tell me, are you ready? We're going to calculate now. You ready? Do you have your pen and pencils with you? I mean pen and papers with you? We'll now begin. Ready? So this is our case, and let's try to solve it using the formula given here. Look on our cases here. Do we have discrete values for the cases here? Do we have discrete values? Anybody from the group? Do we have any discrete values here?
No, doctor, no values.
Yeah, all of them are numerical, right?
Yes.
So what we will do is we're going to use which formula? Which formula we're going to use? Continuous. Very good. Very good. So this is formula 1 and this is formula 2. So we're going to use formula 2 because All of them are expressed in the number. So you need to calculate first the maximum and the minimum, right? So using the formula here, we're going to calculate the maximum and the minimum, correct? So let me just write in here. Let me just write range. Can you see what I'm writing here? Is it clear? Can you see what I'm writing here?
Yes, yes.
Yes, doctor.
Okay, good. So let's try to calculate this. Maximum minus minimum. What's the maximum here?
29.5,
0.5, right? Minus, how about the minimum?
27.01.
27.01 equals tell me what's the value?
2.49.
Sure? Okay, good.
I'm use my head.
You use your head.
Yeah.
So please participate, everybody, okay? Because we need to calculate it properly. $29.5 minus 27.01. Yes, 2.49. Very good, Tarek. Next, how about for Pahang? What is the range here? We have 13.09 minus 10.11, right? Equals 13.09 minus 10.11 equals 2.98, right? Okay, this is for Pahang. Next, how about soy? This is 30.40 minus 20.99, right? Equals 9.41. Is that correct? Next, how about for pecan? Pecan is 21.99 minus 11.09 equals
10.9.
10.9. Correct?
Yes,
Sure?
I'm sure.
Let's see, Mr. Policeman. 21.99 minus 11.09 equals, yes, perfect. Very good. Okay, next. Next, how about Gambang? The last one we have 23.00 minus 19.22, right? Equals, tell me the difference, please. How much?
$3.78.
Yes, 3.78. Very good. So we are now done with the ranges. So the ranges were calculated. Okay, only the attributes you have to calculate. Good. Ready? So we're now done with this. So we calculated the ranges. We can now go with the formula, okay, to know the difference between this and each and every trait here. Okay, so let's calculate this one. So similarity of A and B. A is the new feature, B is the previous feature over the range. Okay, so this is our calculation. So we will start with this one, this and this. Okay, so let me just write here local similarity ls. Okay, so the first given, let me just calculate the first one, and then you're going to calculate the rest, okay, for your assignments, and then you will continue it next meeting, inshallah. But I'm going to finish this one, the dam level. So for the dam level, let's follow the formula here. It says similarity of A and B equals 1 minus A minus B over the range. So we calculated the range already here, so we can now start calculating. So you just have to write something like, so for LS for day 1, LS for okay, LS day 1 for dam, okay, dam, okay, equals 1 minus, okay, the absolute value of A minus B over range. So in this case, we have to calculate the formula, which is A minus B, okay, the absolute value of A minus B, so which is, what is A? A is a new problem, which is 29.5 minus 29.26 divided by the range, right, which is 2.49. So this for the first LS. What's the answer? Tell me, please. So this is 1 minus the absolute value. Where's the absolute value here? This one. So clear. 1 minus the absolute value of 29.5 minus 29.6 divided by 2.49 equals negative 40. I don't think this is the result. Could you please do it for me? 29.5 minus 29.26, we have 0.24. Close parenthesis, divide by 2.49, 1 minus. Okay, so I will have calculator. I just show to you step by step how to calculate it, okay, and then you can do it on your own later on. 0.24 divided by 2.49 equals 0.964. Is that correct? No, 9.64. Sorry, 9.64. What's the answer? Equals how much, please?
8.4.
8.4. Like this? 6.4. Okay, good. So this is how you calculate the first one. Okay, so this one here, meaning the LS for this dam and this dam is 0.8.64. If you're going to multiply this by 1 minus, are we sure this is correct? 1 minus 9.64. This is correct, right? Is it not negative? Please calculate it clearly if you did it properly. Is this correct? 1 minus 0.24 here over 2.49. Please check.
It's minus 9.64.
Minus
9.64.
29.5 minus 29.26. You will get 0.24, right? For this one inside the absolute value here, right? And then divide it.
Doctor, I have a question.
Yes, what question? Tell me, please.
In the ring you use 29.50 minus 2.
This one.
Minus 27.
29.26.
Yes. In the ring you use 29.26 minus 27.01.
No.
But in the similar you use 29.50 minus 29.26. Why use this?
This is the formula. This A here is this minus B, which is this, over the range.
Okay, now understand.
Okay, no problem. Let me just please check this one out if this is correct. 0.24, this is correct here. 29.5 minus 29.26, is it correct? 0.24. Because we have to calculate it properly. 29.5 minus 29.26 equals 0.24, right? Divide by the range,
Right.
which is this.
Right, is correct.
Divide by 2.49, we will get 0. This is 0. This is wrong. Because this one should be the calculator. Let's go back. Clear. 0.24 divided by, this is 0.24 divided by 2.49, we will get 0.096. So I just have to copy this, copy that, and paste it here. Paste. Control V. Copy. And this one here, Control V. So this is not correct. 1 minus, just be patient, okay? This is a little bit challenging for us because we're doing it online. But if it's in the whiteboard, it's very fast. Where's the calculator? I lost it. Calc. So 1 minus Control V, I will get this one, 0.904.
Yes.
Correct?
Correct.
Very good. So it means now, if I'm going to convert this into 100, it means that this dam level here, the new problem, and the feature of the old problem here, they are 90.4% similar. That's the meaning of this. If you're going to convert this to 100, this is actually equivalent to 90.4% in 100, okay? Meaning, if I'm going to compare this and this, they are 90.4% similar. Okay? Next, let's have to do the same process with this, with the day 2 of the dam. So you have to do the same step for LSD day 2 of dam. equals 1 minus the absolute value of, again, 29.5, 29.50 minus 28.99, right? Divide by 2.49. Okay, following this formula here. So this is A1 minus absolute value of A, which is this, minus B, which is this one, divide by the range, which is 2.49 here. So we can do the same calculation as we did with the last one. If you have the calculator with you, this is very fast actually. Right? So let's try to calculate it. So this is 1 minus, this is 2.49 here. Can you please subtract these two? 29.5.
0.51.
0.51. Good. Can you now give me the final answer for this? If you have your calculator, it's very fast. Equals
0.795.
or this equivalent to
79.5%,
79.5%, right?
yes.
So it means that with the observation here, we can say that the dam level on day 2 is 79.5% similar to the dam level on day 5. You have to remember this is day 5, okay? This is day 5. So very far, right? A little bit far, 79.5. So this one is a little bit near, 90.4. But we are not finished. We are only computing for the local similarity. We are not yet finalizing the decision. Okay, I will end up the session now because it's 2 o'clock. So I'll give you the rest as your assignment. And next meeting, I'll be asking one by one to give me the answer. Okay? Okay? I will ask one by one.
Okay.
You can see this in the PowerPoint. Okay? For now, our focus for tomorrow is to calculate only the local similarity. Okay? Only the local similarity. Tomorrow, we're going to finish both local and global. For now, this is your assignment. Solve only for the local similarity. Okay? So when I finish this, I will post this in the chat board, this whiteboard here, so that you will see all the solutions we have done. Any questions so far? Any question you want to ask? Okay. So I'll see you tomorrow for the continuation. Have a nice day. Goodbye.
You too, doctor.
Okay.